Shikar Solvent.
And I am Nathan Neutron.
And this is Nuclear News at 9 in Adamtown. Bring you breaking news straight from the source, piping hot. Nathan, can you please tell us the program today?
Yes, Shikar. This morning we start with a story from the Sea of Electrons. Here, one of our finest cations is interviewing a crazy delocalized electron.
Yes, I'm here with this man named Electric Electron, who seems to have lost his mind. What exactly are you and your negative friends doing here?
We going crazy, bro.
Okay, wow. It seems to me that the electric electron is too hyper for an interview. How unfortunate. He has to move around freely from metal to metal so that his cation fiber can finally become stable.
Very interesting. But some of our viewers may not know exactly what a cation is. I can give a quick run through. Most of us folks are familiar with nonmetals and metals, and how they have similar properties. Metals are well known to lose electrons and become positively charged. These metals are known as cations in the ionically charged state. In contrast, most nonmetals gain electrons and become negatively charged. These anions are the opposite of cations in charge and properties. We were just looking at a positively charged cation reacting with its crazy delocalized electrons.
Great explanation, Shikar. Oh, wow, would you look at that? It's already 9:30. Time to get to your best property deals. This one is off the coast of the Sea of Electrons, and it's nice for your family to rent out. Let's go to Architectural Aluminum near the water.
As you can see, this is a very fine home. Just a fair $12.2 million, you could say.
Go.
Very interesting. Can you tell me some specifics about the house? Maybe some properties about the property?
This house was owned by an elderly metallic couple, and there's an electric wire that conducts electricity. And it is ductile because it is a metal, and it is malleable because it was more flexible than I ever could be. Also, the Sea of Electrons insulates the house and prevents strong repulsions. And everything is super shiny after I cleaned it with my skills. And in the end, everything is super heavy and dense. Metal. 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 Metal again. Oh, it's another metal. 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 And it's another metal. And it's metal.
Fascinating. And what is that liquid that I see next to you?
This special metal solution next to me has a high boiling point as well as a low melting point, just like metallic bonds. Yum, yum, yum in my tum, tum, tum.
Hold on. What is that man doing in the corner? He's breathing like a madman.
Oh, him? Over there? Oh, let's go over to him. This is my friend. His name is Ian Iron, and he was homeless. So I let him stay here. He is chemically unstable because he will react with oxygen. Don't worry if you buy this house. I'll kick him back to the streets.
Thanks Architectural Aluminum for showing these exciting deals to us and their properties. We will be back shortly after a small commercial break.
Boom! Pow! Bang! It fights to the death! If you love jaw-dropping, gut-wrenching, and spit-flying battles, come to the National Arm Wrestling Championship. On our left, we got the rookie, Sterling Silver! And on our right, the reigning champ, Matthew Magnesium. Match begin. Ready up, boys. 3, 2, 1, start. and gentlemen, the decision you've been waiting for. The winner is Sterling Silver, the rookie. He won. What are your secrets?
For the past 6 months, unlike that loser over there, who's training as a natural metal, I've been training as an alloy, so I can be stronger and more stable than any opponent.
If you want to see more matches like that, come join us next time.
Welcome back to Nuclear News in Atomtown. We're now moving past our metallic segment, and this just in. One of our new reporters, Isaac Ionic, has news of electron trades and transfers all over town. Isaac.
There have been numerous reports of new casinos opening all over town, and therefore the amount of transfers has also shot up.
Wow, that is very interesting news. But for the convenience of our viewers, do you mind explaining the basics of the transfer and how exactly these elements go about exchanging such items?
Sure, so basically each element has a charge that they have to gain in valence electrons or lose. This charge number is very important in an element's trade because if they go over or have too little, they can become unstable and break down. This charge determined by the group number allows for a variety of different transfers to occur.
Whoa. Our audience might not even know what valence electrons are. Here, let me give you a quick run through. The valence electrons, which are the outermost electrons, are determined by the group number of the element. These valence electrons also determine the characteristics of the atom. All these atoms are trying to have a full outer shell, so they will either lose or gain electrons. Like Shakar said, positive atoms lose electrons and are called cations, while on the other hand, negative atoms gain electrons, and these are called anions.
This development of electron transfer casinos is very good for the economy of Atomtown, and there's a lot of support from the residents as well.
Yes, and moving from these casinos will take you to a town in the Midwest, Elemental View, where a scientist has made a breakthrough discovery.
Hello world. I would like to show you my new discovery. Come take a look. As you can see, this is what I like to call a crystal lattice.
And what exactly is so special about this crystal lattice?
Well, you see, according to my research, and if my calculations are correct, these bonds are the strongest bonds, and this is because the cations and the anions in the formula, they surround each other totally, making a very stable connection between each other.
Brilliant, and what? Professor, I bring good news!
What is it?
Professor, I finally figured out how to write ionic formulas and name them, and I know how to work dot structures.
Impossible. The chances of that are 1 in 14,605,000.
Professor, I did it. Here, come on, I'll show you. So to name metals, naming ionic compounds, you first name the metals. And group 1s, 2s, silver, zinc, and aluminum, you just name the metal normally. Otherwise, you would name the metal with a Roman numeral, depending on what the charge is. Next, you would name the polyatomic, or you would name the non-metal, and if it's a polyatomic, you use the regular polyatomic ion name, and if it's single, you end it in "ide." For example, sulfide. For writing them, you simply write the symbol with all the oxidation numbers. You do a crisscross, so the numbers flip, but you don't have the sign still. You don't have plus and negative. And then you put parentheses around the polyatomic ions. So for this dot structure, strontium nitride, strontium has a charge of +2 and nitrogen has a charge of -3. So whenever you do the flip-flop, strontium has 3, nitride has 2, and then you have 3 atoms for strontium, 2 for nitride, and this will gain the electrons of this one so that they both have an even octet.
Oh my. Beautiful.
But Professor, that's not it. I also discovered that the greater the electron...
Wait. I know this, but just remind me, what is electronegativity again?
Oh, of course, Professor. Electronegativity is the ability of an atom in a chemical compound to attract electrons.
Oh, I knew that.
Ah, well, I realized that the greater the electronegativity difference, the greater the ionic character. Very, very interesting. This is great scientific discovery, and it provides us with a lot of insight into the lives and structures of ionics. And, Speaking of these structures, we have an architectural aluminum back at it with another house to show us. This, he says, is a deal like none other.
The offer on this ionic bonding house is about $14.7 million. And because it is quite modern and through new technology, it has a very hard and strong crystal lattice structure.
But what does this structure mean exactly?
The way that this neighborhood is set up makes the anions and cations surrounding each other to make sure that the neighborhood is secure from criminals and other forces like that. These houses are secure, hard, and brittle. The strength that is caused by this neighborhood also makes the boiling and melting points high. The houses, though strong, are not the most flexible as they are brittle, meaning they will snap before they bend. One cool feature about the community is whenever there is a flood, their electrical generators kick into full power and work faster than ever.
That is an amazing deal, folks. And if you find you're interested in buying this house or others nearby, contact Architectural Aluminum for more information.
Well, this has been it for today's show, folks. 1 hour really flies by when you're having fun.
Thank you for watching Nuclear News on ATOM, your spot for the newest and most trending atom stories. Thank you to our producers Brozar and Day Studios. This is Nathan Nuclear.
And Shakar Solvent.
Thank you for watching, and have a great rest of your day.